Good evening, all. Hope you are doing well. So, this is a continuation of environmental engineering part 1. This lecture will cover water pollution, impurities of water, and their effects, need to treat water, and water quality parameters, which includes physical, chemical, and biological. First, we have water pollutants, which may be organic or inorganic. Here you can see in the photographs that water is like cloudy appearance. So we have definition that water pollution is a term used to indicate an act of contaminating or making foul natural water bodies such as rivers, stream, wells, and it may be the other sources like canals. We have difference between pollution and contamination of water. On left side we have pollution and on right side we have contamination, so we can compare both of these terms because most of us we are confused to define these terms. So pollution is the general term and it includes contamination also, but contamination particularly, it is the specific term of indicating pollution. Pollution, it makes the water unfit for the best use, and contamination, it makes the water unsafe and unreliable for use. In pollution, the polluted water is objectionable to the human sense of sight, smell, feel, and taste. But on other side, in contamination, the contaminated water may not be apparently objectionable. And the last point in pollution is the illustration of polluted water or colored water, saline water, foul smelling water, water containing floating bodies, oil, grease, and other parts. In contamination, the illustration of contaminated water or water containing high concentration of harmful or pathogenic bacteria and other microorganisms. We have here types of water pollutants. There are two major water pollutants which are organic and inorganics. Pollution of water occurs due to following factors. As I told you that one is inorganic and other are organics. In inorganic substances, the presence of toxic inorganic compounds are dissolved in inorganic substances, all suspended inorganic substances. Here we have detail of toxic inorganic compounds that certain inorganic compounds are toxic to fish and other aquatic life. These compounds are derived from industrial wastes of certain industries such as fertilizers, coke ovens, gas liquids, alkali producing factories, and many sources. But these are the important ones. And the important toxic inorganic compounds, including free chlorine, chloramines, hydrogen sulfides, H2S, soluble sulfides, ammonia, and salt of many metals such as chromium, lead, nickel, copper, uranium, mercury, silver, zinc, and other heavy metals are uh, chlorides. On the other side, we have dissolved inorganic substances. The dissolved inorganic chemical substances include minerals and gases derived either naturally or from certain industrial wastes, and when they are present in small concentrations, they are harmless to fish and other aquatic life. Means, if we conclude this point, that if they are in limited concentration, then it is harmless to fish or aquatic life. But if they are in higher quantity, They are dangerous to aquatic life, especially the fishes. The table in the next slide shows the effects developed by presence of different minerals and gases in water. Here you can see dissolved inorganic chemical substances. Here we have serial number 1, 2, 3, 4, 5, 6, and dissolved minerals or gases and their effects. Number one are bicarbonates, carbonates, chlorides, and sulfates of calcium, magnesium, and sodium, iron oxide, manganese, carbon dioxide, CO2, H2S, hydrogen sulfide, and oxygen. What are their effects? Alkalinity, hardness, and taste effects. Hardness, red color; taste, black or brown color; taste, corrosion to metals; acidity, corrosion to metals; odor, and corrosion to metals. These are the effects by bicarbonates, carbonates, chlorides, sulfides, and calcium and other substances like iron oxide, manganese, carbon dioxide, hydrogen sulfide, and oxygen. And number third are suspended inorganic substances. The suspended inorganic substances include particles of clay, sand, silt. The effect of these substances is to impart stability to water. Means if the clay or sand or silt particles are available in water, water would be called as turbid because water is turbid because of these substances. As I shown you in the last slide, there was a photo. I shown you that when you have cloudy sort of appearance of inside the water, you can say that water is turbid, and the property is called turbidity of water. Then we after inorganic we have organic substances. The most common form of pollution of water due to organic chemical is due to the presence of fats, proteins, carbohydrates, and other organic substances. These organic chemicals get access to water bodies either through sewage or through industrial wastes. The important industries which contribute such chemicals are those of drugs, dyestuffs, insecticides, pesticides, chemicals, and detergents mainly. Following are the forms of organic pollution of water. One are suspended organic substances and others are dissolved organic substances. Organic substances, suspended organic substances are chemical substances developed due to presence of certain industrial wastes or vegetables or animals. The vegetables may be in the form of algae, decayed leaves, fungi, and they impart acidity, green or brown color, and taste to the water. The animals may be in the form of insects, dead animals, and they are considered responsible for the growth of bacteria inside the water body. On other side, we have also dissolved organic substances. The dissolved organic chemical substances develop due to the presence of certain industrial wastes or due to decay of vegetables and animals. In this case, water contains large quantity of albuminide ammonia with large quantity of free ammonia and chlorides. Such water is likely to contain pathogenic or disease creating bacteria, and hence it is to be considered as very dangerous to the public health. Here we have impurities in water. Pure water can never be available in nature. Even a man-made drop of water prepared in a laboratory by lighting the hydrogen and oxygen gases in a test tube may not be perfectly pure because the water drop so formed will dissolve the glass of the test tube, although a very little bit. Similarly, the rainwater at the instant of its formation contains no impurities, but during the process of formation and fall through the Earth's atmosphere, it may dissolve certain gases, traces of minerals, and other substances. So, this is the discussion for the impurities in water. We have continued this topic impurities in water. As the rainwater flows over the surface of earth, it picks up dissolved particles of soil, garbage, sewage, pesticides, and other human animals or chemical wastes. It may also pick up and dissolve certain decayed organic materials such as plants and dead animals. If the surface water seeps into the groundwater reservoir, most of the suspended particles are filtered out. But on the other hand, the water dissolves the minerals and salt present in the earth's layer, through which it travels before joining the water table. So, what could be the effects of these impurities on water? Sometimes the impurities which water dissolved or picks up is sustainable, making it more useful and suitable for public use and especially for drinking. And sometimes it may render it harmful and unfit. For example, the certain minerals such as iron, calcium, magnesium, fluorides, fluorine in small quantities may be useful and good for the health of the people because human beings need a certain amount of these elements in their bodies. But when these materials and others are dissolved in a large amount, means their concentration, if their concentration are high in a certain combination, the water may become unfit or less useful for municipal, industrial, and other uses. For example, sometimes the water may contain toxic or poisonous substances such as arsenic, barium, cadmium, chromium, cyanide, lead, selenium, silver, and copper etc., which may be very harmful to the public health even if present in a very low quantity or low concentration. Sometimes the water may contain too much of common, thereby rendering it brackish and making it undrinkable and less useful for cloth washing or for irrigation and farming. Similarly, sometimes the water may contain harmful bacteria, the presence of which may cause disease such as cholera, typhoid, dysentery, gastroenteritis, infectious hepatitis, and then get disease which are caused by the water due to its impurity. So after all discussion, we have here major discussion that why definitely if water contains such sort of impurities, so then we have a need for treatment because our final or ultimate goal is to supply the water to communities without impurities. So definitely, if water is impure, so what we have to treat the water. So this slide contains that need for the treatment to ensure safety to public health. economy and utility in industries and other uses. It therefore becomes imperative upon the planners and designers of the public water supply schemes to thoroughly check, analyze, and treat the raw available water to safe and permissible limits before supplying to the consumers or public. Now we have a next topic that what types of water pollution are simply we can if we simplify this line that water is available or water impurities could be in different forms like physical, chemical, and biological. Or simply we can say that characteristics of water. Or, or lastly we have water quality parameters. So if examiner asks you that what are types of water pollution, you have to write same thing. Or he may ask you write physical, chemical, and biological properties. Okay, the thing is same. And the third or a third is characteristics of water means he's asking you the water quality parameters. So all our other things it depends upon the examiner, but you have to be clear that these all three or four terms are used for the same thing, which are water quality parameters or physical, chemical, and biological properties of water. First, we have small overview that physical, chemical, and biological characters of water. The raw or treated water means raw water is known as before its treatment. So the raw or treated water can be checked and analyzed by studying their physical, chemical, and microbiological characteristics or features. Introduction. Water quality is determined by physical, chemical, and microbiological properties of water. These water quality characteristics throughout the world are characterized with five variability. So first we have physical characteristics or physical properties of water. That physical properties are characteristics of water content, temperature, color, taste, and odor etc. are determined by senses of touch, sight, smell, and taste. For example, temperature by touch, color floating, debris, stability, and suspended solids by sight, and taste and odor. So here we have a list of different physical properties which contain turbidity, color, taste, or odor, temperature, and specific conductivity. Then we have turbidity. Turbidity is a measure of the light transmitting properties of water and is comprised by comprised of suspended and colloidal materials. Therefore, it is important for health and aesthetic reasons. And we have photographs of different jars with of turbidity. So turbidity is measured in NTU unit. Here you can see that this water is clear, this is little clear, this is more unclear, and the last one is more unclear. Okay. So here you can also see there is a values in NTU. The first one, which is clear water containing bottle, is 25 NTU. Then other is little unclear, which is 100 NTU. Then third one, our middle one is 500 NTU. The second last is 1000 NTU, and the last one are 200 2000 sorry, 2000 NTU. So the water which is with the clear appearance has less NTU value of 25. This is for just for your clear understanding that If water is clear, then we have less value. If water is more turbid, we have higher value in NTU, potability. Potability is the cloudiness or smokiness of a fluid caused by a large number of individual particles that are generally invisible to naked eye. Turbidity is a measure of water clarity. How much the material suspended in the water decreases the passage of light through the water. Suspended materials including soil particles, including clay, silt, and sand, algae, plankton, microbes, and other substances. We have different turbidity unit. Here we have a discussion on the unit of turbidity because turbidity is measured in different units. Most commonly, unit is MPa. We have also other type of units which are used in other like different countries. So Jackson turbidity unit, an absolute unit used in measuring the clarity of water, also called a Jackson unit, relied on the human eye. The flame of the cylinder candle was viewed through a vertical tube. The tube was gradually filled with the water to be measured until the flame was no longer visible. The depth of water in the tube, which had a scale marked in U, indicating the turbidity. Both the unit and the measuring techniques are absolute. However, the measurement in the units that replaced it, NTU or FTU, are numerically close to BTU measurements, but with a much lower margin of. You can see the nephrometer, which is used to measure the turbidity. The turbidity measured by an instrument called a nephrometer, with the detector set up to the side of the light beam. More light reaches the detector if there are lots of small particles scattering the source beam than if there are few. The units of turbidity are JTU, Jackson turbidity unit, NTU, nephelometric turbidity unit, and FTU or FNU, Farmas, Farmazen nephelometric unit. So we have next physical property, which is temperature. Observing the temperature of the water has usually no practical significance in sense that it is not usually possible to give any treatment to control the temperature of water. However, we mentioned that for potable waters, temperatures of about 10 degrees centigrade are highly desirable, while temperatures above 25 degrees centigrade are considered objectionable. Here we have continuation of temperature. The temperature of water affects some of the important physical properties and characteristics of water. For example, density, specific weight, viscosity, salinity, and solubility of dissolved gases and some other material. Chemical and biological reaction rate increases with increasing temperature. And the reaction rate usually assumes to double for an increase in temperature of 10 degrees centigrade. Then we have color. Color in water is primarily a concern of water quality for aesthetic reasons. Colored water gives the appearance of being unfit to drink, even though the water may be perfectly safe for public use. Color also indicates the presence of organic substances such as algae or humic compounds. What is humic? A dark ground organic component of soil that is derived from decomposed plant and animals remain the animal. Color analysis is done by visual comparison to a set of platinum cobalt standard in Nestlab tubes. Color in water is the result of dissolved extract from metal in rocks, soil, organic matter in soil and plants, and industry and industrial byproducts. Taste and odor. Taste and odor are human perceptions of water quality. Human human perception of taste includes sour, salty, sweet, and bitter. If water is sour, then there is hydrochloric acid inside the water. If water is salty, then definitely the sodium chloride is available in higher concentrations in the water. If water is sweet, means there is possible, not possible, but 100% involvement of the compound or element. And if water is bitter, means water is the mix of caffeine. In taste and odor, relatively simple compounds produce sour and salty taste. However, sweet and bitter taste are produced by more complex organic compounds. Organic materials discharged into water, running leaf, runoff are source of taste and odor. The taste of water may be due to addition of any chemical or mineral concentration. What I told you, that taste of water is due to addition of any chemical or mineral concentration. If strong chloride taste or smell, generally this occurs when the water is treated at the water treatment plant for disinfection. And the addition of chlorine is used to kill off bacteria and other harmful microorganisms. Metallic taste. Some water systems have a high mineral concentrations, giving the consumer a salty or soda taste. In the case of iron and manganese, a strong metallic taste is readily detected. Odor. Rotten egg odor. This is usually a result of decaying organic matters such water produces hydrogen sulfide H2S gas. Hydrogen sulfide or H2S gas can be corrosive to plumbing at high concentrations and can discolor silver rapidly. And in order in large enough quantities, it is toxic to aquarium fish. As little as 0.5 ppm parts per million can be noticed in drinking water. Then we have solids. In the water is defined as the residue remaining after water and drying the residue to a constant weight at 103 degrees centigrade to get to 505 degrees centigrade. The organic fractions are volatile solids contain is considered to be related to the loss of weight of the residue remaining after evaporation of the water and after ignition of the residue at the temperature of 500 degrees centigrade. The inorganic are fixed solids remain as inert reaction. Then we have specific conductivity. Specific conductance is a measure of the ability of water to conduct an electrical current. Specific conductance is an important water quality measurement because it gives a good idea of the amount of dissolved materials inside the water. Conductivity increases with increasing amount and mobility of the ions. It is highly dependent on the amount of dissolved solids such as salt in the water. Pure water such as distilled water will have a very low specific conductance and seawater will have a high specific conductance due to presence of salts inside the water bodies. Rainwater often dissolved airborne gases and airborne dust while it is in the air and thus often has a higher specific conductance than distilled water. High specific conductance can affect the suitability of water for domestic, industrial, and agriculture. At higher levels, drinking water may have an unpleasant taste or odor, or may even cause gastrointestinal incidents. Additionally, high dissolved solids concentrations can cause deterioration of plumbing fixtures and appliances. Relatively expensive water treatment processes such as reverse osmosis are needed to improve excessive dissolved solids from water. Measurement of specific conductivity. The specific conductivity of water is determined by means of potable ionic water tester integrity meter and is expressed in micro ohms per cm centimeter at 25 degrees. MHO is a unit of conductivity and equal equals 1 ampere per 1 volt. The specific conductivity of water in micro uh, mHOs per cm at 25 degrees centigrade at 25 is multiplied by a coefficient generally 0.65 so that directly obtain the dissolved salt content TDS in milligrams per liter ppm. We have very important features or characteristics of water which are chemical. So we have chemical characteristics of water. The chemical characteristics of natural water are a reflection of the soil and rocks with which the water has been in contact. In addition, agricultural and urban runoff and municipal and industrial treated wastewater impact the water quality. Chemical properties are chemical analysis of water is carried out in order to determine the chemical characteristic of water. This involves tests for determining the total solids and suspended solids, pH value, hardness, chloride content, nitrogen content, iron, manganese, and other metal content, and dissolved gases. Total solids and suspended solids. Total solids means the suspended as well as dissolved solids present in water. So TS means total solids are dissolved solids plus suspended solids. It can be determined by evaporating a sample of water and weighing the dry residue left. Total solids and suspended solids. Suspended solids can be found by filtering the water sample and weighing the residue left on the filter paper. The difference between the total solids and the suspended solids will then represent nothing but the dissolved solids. So dissolved solids is equal to TS minus SS. The total permissible amount of dissolved solids in water is generally limited to, although higher amounts up to 1,000 ppm, and also sometimes fermented. We have minerals. Runoff causes erosion and weathering of geological formation, rocks and soils in the runoff travels to the surface water body. During this period of contact with the rocks and soils, the water dissolved in minerals. Inorganic compounds may dissociate, varying degrees to cations and cations and anions. Major cations found in natural water including calcium, Ca2 plus, magnesium, Mg2 plus, sodium, Na plus, and potassium capital. And major anions include chloride, sulfate, carbonate, bicarbonate, chloride, and nitrate. Bicarbonate HCO3 is the principal anion found in the natural carbonate equilibrium. The carbonate bicarbonate system is presumably the most important chemical system in natural waters. The carbonate system provides the buffering capacity essential for maintaining the pH of natural water system in the range required by bacteria and other aquatic species. Then next we have alkalinity and pH. Alkalinity is defined as the capacity of natural water to neutralize acid added to it. Total alkalinity includes hydroxide alkalinity (OH), bicarbonate alkalinity (HCO3), and carbonate alkalinity (CO3). In acidity is the quantitative capacity of aqueous media to react with hydroxyl ions. Titration with a strong base NaOH to define endpoints. pH is equal to 4.3 and pH is equal to 8.3. Acidity indicates the corrosiveness of acidic water on steel, concrete, and other materials. pH value of the water. The pH value of water indicates the logarithm of reciprocal of hydrogen ion concentrations present in water. It is thus an indicator of the acidity or the alkalinity of water. Since the pH is the log of reciprocal of hydrogen ion plus ions, the higher values of pH means lower hydrogen ion concentrations and thus represent alkaline solution, whereas the lower values of pH means higher hydrogen ion concentrations, representing acidic solution. Pure water is a balanced combination of positively charged hydrogen ions plus and negative charged hydroxide ions, not OH. In pure or neutral waters, their number is equal. The product of concentration of H ions and concentration of OH ions in a water solution is constant. This constant has been found to be equal to 10 power minus 14 moles per liter. How a neutral water becomes acidic. If an acidic is added to a neutral or pure water, the number of hydrogen ions will decrease because of the hydrogen content in the acid. For example, if hydrochloric acid is dissolved in water, the dissociation becomes H2O will break in hydrogen and OH ions, and HCl will broken H and hydrogen and chlorine. Then the net concentration of hydrogen ions will exceed that of hydroxyl ions and will be more than the hydrogen ion concentrations of neutral water and thus decreasing the pH value to less then 7, and thereby making the water acidic. Hence, if the pH of the water is more than 7, it will be alkaline, and if it is less than 7, it will be acidic. The maximum acidity will lie at zero value of pH, and the maximum alkalinity will be at value of pH equal to 14. How we can measure the pH? The pH value of water can be measured quickly and automatically with the help of potentiometer, which measures the electrical potential exerted by hydrogen ions and thus indicating their concentration. It can also be measured within the help of color indicators dyes, which are added to water, and the color produced in is compared with the standard color of known pH values. The permissible pH value for public supplies may range between 6.6 to 8.5. Then we have hardness of water. So we will discuss this hardness of water in our next lecture. So thanks for watching.